In recent years, the detection of AI-generated text has become a critical area of research due to growing concerns about academic integrity, the spread of misinformation, and the ethical use of artificial intelligence. This paper, titled OSINT at CT2 AI-generated text detection, tracing thought, is authored by Shifali Agrahari and Sanasam Ranbir Singh from the Department of Computer Science and Engineering at the Indian Institute of Technology Guwahati in India. The researchers propose a novel framework called COT Fine-tuned, which stands for Chain of Thought Fine-tuning, designed to not only detect whether text is generated by AI or written by humans but also to identify the specific language model responsible for creating it. At the core of this framework is a dual-task approach. Task A is a binary classification problem, where the system determines if a given text document was produced by an AI or crafted by a human. This is essential because AI-generated text can be highly realistic, making it difficult to spot without advanced tools. Task B builds on this by assuming the text is AI-generated and then pinpointing exactly which language model created it. The models in question include popular ones like GPT-4, Deberta, Falcon Mamba, PHI 3.5, and others. This level of specificity is crucial for understanding the origins of AI content, which can help in addressing issues like plagiarism or biased AI outputs. The key innovation in COT Fine-tuned is the use of chain of thought reasoning, or COT. This technique involves training the model to break down its decision-making process into a series of logical steps, much like how a human might think aloud when solving a problem. For example, instead of just outputting a simple, AI-generated label, the model generates an explanation that outlines the reasoning behind its classification. This could include analyzing patterns in the text, such as repetitive phrasing, unnatural fluency, or specific stylistic markers that are characteristic of certain LLMs. By doing so, COT enhances the transparency and interpretability of the model, making it easier for users to trust and understand its predictions. To implement this, the researchers fine-tune a pre-trained language model on a dataset that includes both human-written and AI-generated texts. The fine-tuning process is adapted to handle both tasks simultaneously. For Task A, the model learns to classify text based on features like syntactic complexity, vocabulary diversity, and semantic coherence. In Task B, it delves deeper into subtle differences between LLMs, such as how GPT-4 might produce more creative and varied outputs compared to Deberta, which could exhibit more structured and predictable patterns. The chain of thought aspect is integrated by prompting the model to generate explanatory sequences during training, which helps it learn to justify its classifications. The paper draws from the context of the AAAI 2025 Defactify 4.0 workshop, which focuses on multimodal fact-checking and hate speech detection, specifically the CT2 task on AI-generated text. This workshop provides a competitive setting where participants tackle these detection challenges, and the author's framework is positioned as a strong contender. Experiments conducted in the study show that COT Fine-tuned achieves high accuracy in both tasks. For instance, in Task A, the model demonstrates robust performance in distinguishing AI from human text, with metrics like precision and recall exceeding those of baseline methods. In Task B, it successfully identifies the specific LLM with strong results, particularly when dealing with texts from models like GPT-4 or PHI 3.5. One of the standout findings is how COT reasoning contributes to the model's effectiveness. By generating explanations, the framework not only improves accuracy but also provides valuable insights into why certain texts are classified a particular way. For example, the model might explain that a text's repetitive use of advanced vocabulary points to an LLM like Falcon Mamba, which is known for its efficiency in generating technical content. This interpretability is a significant advancement over traditional black box AI detectors, as it allows researchers, educators, and policymakers to better understand and audit the detection process. In terms of related work, the paper situates COT Fine-tuned within the broader landscape of AI-generated text detection. Existing methods are often categorized into supervised, unsupervised, and hybrid approaches. Supervised methods, which rely on labeled datasets, have been explored in studies like those referenced in the paper, showing strong performance but with risks of overfitting to specific data. Unsupervised methods detect anomalies without labels, while hybrid approaches combine elements for better generalization. The authors argue that their COT-based framework improves upon these by adding explainability, which is often lacking in prior models. The experiments also highlight the framework's ability to handle real-world challenges, such as variations in text length, topics, and the evolving capabilities of LLMs. For instance, the researchers tested COT Fine-tuned on diverse datasets, including those from the Defactify workshop, and found that it maintains high performance even with adversarial examples, texts designed to evade detection. This robustness is attributed to the step-by-step reasoning process, which helps the model adapt to new patterns. Overall, the COT Fine-tuned framework represents a promising step forward in AI ethics and safety. By combining accurate detection with interpretable explanations, it addresses key concerns in fields like journalism, education, and content moderation. The paper emphasizes that as language models continue to advance, tools like this will be essential for maintaining trust in digital information ecosystems. The authors conclude their work by noting the potential for further extensions, such as integrating multimodal data or applying the framework to other languages beyond English. In practical terms, this research could be applied in various scenarios. For example, online platforms could use COT Fine-tuned to automatically flag AI-generated articles or social media posts, providing users with explanations to build awareness. In academia, it could help verify the originality of student submissions, while in legal contexts, it might assist in investigating misinformation campaigns. The framework's open-source potential, as indicated by the paper's Creative Commons license, encourages further community contributions and adaptations. To wrap up the technical details, the paper includes a figure illustrating the detector model for both tasks, showing how inputs are processed through the COT mechanism to produce classifications and explanations. The authors, Shifali Agrahari and Sanasam Ranbir Singh, can be contacted via their provided email addresses for more information. This work was presented at the Defactify 4 workshop, underscoring its relevance to ongoing discussions in AI accountability.